Good morning. It is Saturday, July 15th. Bringing it back to work. Let's see, what are we going to be doing today? What am I going to be doing today? Well, let's see. Some of the stuff that we were trying to work on last time. We're going to get the rotation of the waterfalls working properly. We're going to take a stab at... Yeah, those are the same task. Good morning, Karakan. I hope you are doing well today. I am just getting started. You know, what better time to start your day than 3:20 in the morning, right? Like, I am not a normal person. So we're going to look into, I'm going to try to order these tasks a little bit. I think it's going to be the rotation stuff. Then we want to look at that edge, the edges of the waterfall, maybe deforming those properly. And we'll want, I'm going to see if there's any subsurface lighting. It's 12 p.m. there. Very good. Yeah, that's about right. It was a joke in college. Like our professor, freshman year, one of them, he had his class at like 12:30 in the afternoon, and everybody would, like inevitably people would sleep in. He'd be like, "Oh man, it's just so hard to get up at the crack of noon and drag yourself to class." Just like no sympathy from that guy. Alright, so rotations. And hopefully what we can do today is we want to finish up the waterfalls and get those good to go. If we can actually get to doing the real water stuff, like the actual surface water, then that's good. I don't think we're going to be messing too much with particle effects for the waterfall. We're just trying to get the waterfall thing. Playing some Risk of Rain? Alright, well, try to stay alive. Though I highly doubt you'll be successful. There's a lot of death. There's a lot of deaths in that game. More water. Yeah, it's all water all the time. We're going to be doing probably water. I mean, this whole piece of concept art that we're working on is water. It's going to be a while. Because this thing is all water. Everything is wet. Even Bitey's wet. You can tell his fur is all drooping down. It looks like he just got out of it. Like we got foliage and just all this garbage is going to be all about water. Alright, so let's start messing with these rotations. So we want to get this. If you just die, repeat, yeah. So let's get this guy, and what we want to do is we want to make it so when we rotate this object that it properly rotates itself. So let's go take a look here. So it's test content, water, we got waterfall blueprint, we've got the test waterfall material. My hair is getting frizzy, yeah. Alright, so what we're doing is we're rotating these vectors based on the yaw of this thing. So we want to know... I'm going to need to grab a piece of paper here. I can always tell when I'm going to do some math, I'm going to need to write some stuff down. Alright, so we're going to get our actor's rotation. We're going to break the rotator, grab the yaw off of it, subtract 90 because we're already rotated by 90 degrees. And then we're going to rotate our basis vectors and set U and V basis vectors. Alright, the U basis is the y-axis rotated around. And I think we confirmed that the basis vectors were correct before. Though I'm not really sure, I think we just kind of left off. So we got top right, we got the basis vectors and all that stuff. So... what exactly is going on here for this? So we rotate it this way. We rotate it 90 degrees and... well, that looks proper. Like that's not messed up completely. What's this 45-degree angle that is messed up? So we can rotate it 90 degrees and it works. But it's this 45-degree angle . It's like we're rotating the wrong direction or something, right? Well, why don't we just try stabbing it in the dark? What happens if we multiply it by -1? Well, clearly that doesn't work. Well, I think what's going on here is it's actually working pretty well. The issue is that our width is wrong. Like, everything else is looking proper. It's just that the width calculations are incorrect. So the width calculation is The best thing for us to do here is to actually plug in the values that we see. So if we stop previewing a node and we go through and we're like, well, what are these vectors going to be? Like if we do 0.5 and 0.5, let's actually rotate this and see what values we're actually getting. Of course, we can't put any values, any breakpoints in these things, so we're going to have to print this out. Alright, so we're going to say the U basis is going to be this, comma V basis. We'll add a pin here, print that out as well. Slot that in, let's compile that out, let's see what it looks like. Okay, so at what's the degree that we're at? We're at 50. So if we're at 0, so if we're at 45. We're at 45, yeah, this is what we have. We've got $707, and for X, and the V basis is 1 for Z. Well, that's correct. Z is always going to be 1. It's going to be what is, because it's always going to be straight up and down pretty much. So 0.7, 0.7. So what we've got here is we've got our waterfall. And it looks something like this. So it's 0.7, 0.7, 0. Alright. Well, it's good to know. Let's plug those values into our test thing here. So it's 0.7, 0.7. So 0.707. Did it change all of them? Ah, looks like it did. Alright. And is that what we're seeing in the game? No, we're seeing this. Alright, well, whatever. Okay, so what are we actually doing with our values? And this is kind of some of the issue with blueprint math, is it just gets kind of ridiculous. So I gotta figure out what the hell I was doing. Alright, so here we've got the absolute world position of this thing. Well, we were trying to figure out what is the width of this thing. Yeah, we're doing all this in world space. I don't think this preview is going to be very helpful, actually. Not for this, yeah. So we're taking the bottom left. Alright, so we have the top right and the bottom left, and I think we were trying to map it from, this was 0, 0, and this was 1, 1. That's what we were trying to do. So when we look at this value, like it's supposed to go from 0 to 1 and 0 to 1, and this will be 1, 1 down there. So that's kind of the idea. And when we rotate this thing, we're not going from 0 to 1 anymore, for some reason. Well, is it that our object bounds are just wrong? Like, we already have... Is it that our bounds are actually, the box extents are rotated? So what's going to happen is we're kind of double rotating. So maybe it's that we don't actually need to rotate any of this, because the extents are already going to work with this. I'm trying to think, and of course this is just the boring part of hello Kento 456. It's fine Friday. Is it still Friday? Nah, it's Saturday now over here. So Friday is gone. It's gone away. But yeah, I'm doing math, which means I'm confused and just trying to figure out what I'm doing wrong, which is the we're needing to rotate these waterfalls, and they are wrong in basically 4 cases. Like, they're right on all the 90-degree stuff, but then they're like doing the opposite of what they should be doing. Like, this is too big, goes to 0, goes to 0. So I'm trying to rework kind of what I was working on before. So we get our bottom left and our top right of our object, and we want to map that from 0 to 1 in world space. So if we got the bottom left and we have the top right, I'm going to take the world space position to get my U. I'm going to take the world space position what it's going to be the length of the vector between, it's going to be the distance between these extents divided by, because the V is correct, it's the U that's wrong. Yeah, it's the U that's wrong. Remember that. I've got my little piece of paper here. I'm working it out. So to get the U is going to be it's going to be the distance along the vector divided by the total length of the vector, which is going to be the extents. So if I have this vector here in 3-dimensional space, I need to project it onto the plane. See if I can draw some of this. So we've got our bottom left and top right, and when we're looking straight on, basically our V is going to be always the Z-axis. You know, it's just like we get the height of the object. So, you know, the V is going to be so Z is up, and Y is going to be something else. So, I mean, I guess what could we do to to map this stuff properly. We could rotate this thing back. We could give like a rotation. We could, transform this thing so that we're always dealing with, left and right sort of stuff is like the y-axis. But we've got a basis, we got a rotated vector, and that vector we can project onto. And so the u is going to be the, like, we got a point here, it's going to be this length here, so it's going to be this width. It's basically the y divided by the width, but in this case the y is something else. The y is not this value. It's like we basically want to take this right here, this vector, and project it onto this. So we've got these two vectors here. And if we project them onto this base vector, we'll get the magnitude of those vectors is going to give us our u. So do we have vector projection stuff here? Like, we have dot products and cross products and stuff. Let's see. Got absolute, arc cosine, cosine, divide, power, quadratic formula, round, safe, normalize, sines, remap, sine, tangents, transform 3x3 matrix, transform to clip space, vector to radial value. Hello, Unwhy. We're just working on rotating some stuff. I'm probably making this a lot harder than it needs to be. It's really this u that's wrong. So it's we basically got our vector here, which is going to be our world position multiplied by our basis vector. Do we need to multiply by our basis vector at all? Like, this is going to take our world position, which will be like, you know, something like 0, 1. So take something like 1, 1. Yeah, I should start on, like, what if we had a point right here? How would we know? What would the math look like? It would take 1, 1 and we multiply it out. So it's not going to be 1, 1. Well, crap. Rotations. Why? So it's the intermediate stuff that's messed up. Yeah, this is always the fun part of game dev stuff, is when you're doing math. And especially, it must be really boring to watch on stream because I'm just like, what the fuck am I doing? I can't even really get a good example of what it looks like going here nicely. So it's going to be like it's like 0.707, 0.707 for x. So the x value is going to creep in here. The extents are going to be changed, and the basis is going to be changed too. Like, we're not dealing with the same box values. And this is all in world space, so it's basically, we've got this box in world space. And we're multiplying it by this basis vector, so we're going to have like more of the x and all that sort of stuff, so it'll be like 0.7, 0.7. So it's this u value here is too big on some things and then too small on others. So this goes from 0 to 1 as we go across, and the reason for that is because I can't rotate this damned object. Though maybe I can look at this cylinder? No, doesn't work. Crap. This is just not clicking. It has something to do with just rotating this thing. I mean, let's just look at what the vector projection formula is. You know, I fucking hate math formula stuff. Like, I really like code with stuff like math because it tells you exactly what you're supposed to do. It's always like, you know, oh, just, you know, you need the angle or something. You'd be like, yeah, I get it, but, you know, just tell me, like, what to multiply in order to get this thing to work. So it's like the scalar projection is equivalent to this. It'd be like, yeah, I don't really give a shit. Just tell me exactly the formula for it. Like, and instead they've got, like, you know, 2 million different things. Too much random ass information. So you have to read the whole damn thing. Just be like, well, what's the actual formula? So it's just a times b divided by the magnitude of b? Is that... It's been a while since I think that's what the two bars on the fucking side are. But that's kind of what we're doing right here with these basis vectors. Shouldn't there be a library or helper? Well, that's what I already looked for. There's no projection formula in here. I think that was literally the first thing I looked for. Was, hey, there should be like a project vector sort of thing, right? No. And if it's just a times b, we already have b, which is the this basis vector right here, and we're already multiplying our world position by that to get our stuff, and this is a unit vector right here already with the basis. So we've already done our vector projection, and the same thing here is we're projecting our bottom left and our top right onto the basis and doing the same thing with it. So supposedly, let's wonder. I can take photos of it. Well, thanks for the offer, Lucas, but just enjoy your time out there. So we're already doing the projection. So what must be happening is, Like, we must have a degenerate case here, or something is wrong with our angle. Like we're rotating about the z-axis. Is it that we have a negative value here when we shouldn't, or something? Like, something is just the opposite of what it should be, is what it seems like. I thought he'd enjoy your time out. Yes. No. So what's happening is we're shortening. Like, we're expanding the vector, like we're expanding the space, and here we're shrinking it because it gets clamped to the sides. So what's happening is the U is, like, this is where it starts at 0 and this is where it goes to 1. It should be over on those sides. I think it might have to do with our top left and bottom right are wrong somehow. Like, these two things, these component bounds on our waterfall mesh are changing every time, and they're incorrect somehow. Like, what we should be doing is passing in the unrotated versions of this, or something like that. Because we're going along the right areas, it's just that there's something wrong with the bounds, is what it seems like. Or maybe the box extents and everything else, maybe they're not changing when they should be, would be another thing. Not as excited without video feed. Yeah, that's true. I don't know if Adam's streaming. So we'll see. I haven't really said much to him. He's been super busy. Alright, so why don't I just print out some of these vectors. Because I think the extents here are what's screwed up. Are you still too busy to be streaming? Yeah, that's kind of what I figured. Something like that would happen. Well, it's definitely changing the top right and all that sort of stuff. The bottom left and the top right. To construct two? No, I'm unfamiliar with that. I don't think I've ever heard of it. So we have the bottom left and the bottom right. Alright, let's just take a look at our formula here. So we're taking the... We're going to multiply this out, project it onto the basis vector, and then we're going to subtract our current position in the world by our bottom left. So we're going to take our current position, we're going to subtract our bottom left from it. Our current position minus the bottom left is going to get us the vector from the bottom left to where we are. We are then going to divide that by, we are subtracting the top right minus bottom left. Alright, so top right minus bottom left. So we're taking our current vector, our position basically, divided by our total, by our width. And we're making a float 2 out of it. Well, where are we grabbing the X or Y or whatever the hell out of this? Like, we made a float 2 out of this value, but isn't this a vector? Like, what the hell did we do to turn this vector into a thing, right? Like, we have 0, 1, 0, blah. So if we're taking a float 2 out of this thing, how do we actually... We're adding all the values together? Okay, so this is where input a float 2 and add all the values together. So we're going to multiply this. We don't want to do this. Like, adding them together is wrong, right? We should be taking the length of it. So we need the size of this vector. We project it on, and then we want to get not to add these things together. We just want the magnitude of it. So this is wrong. The add components. We want the there's no magnitude. Is there a length? Vector length? Alright, so we're going to do vector length here. So it should be something like this. Instead of these add components, we need the length. We need to do it like that. Because adding them together is not correct, and adding them together is going to give us the wrong thing. So we need to compile all of our shaders. Huh. So it's all sorts of screwed up. Well, now it's just rotating the wrong way. Is it? I mean, it's the length of the vector, and we're going to subtract. We projected this thing on there and got the vector length. So this is the length of the vector. Yeah, we basically projected onto our basis vector with our thing, and so it should just be we subtract our current position by that, and that'll give us our current length. And then we divide it by the magnitude of these two, like the bottom left and top right on the basis vector. So it's the top right, then we got the vector length, and we subtract the top right Alright, so this thing just returns the distance. The distance from 0, so this is the vector length. Alright, so that's distance computes the Euclidean distance between 2 points, colors, and positions. This works on 1, 2, 3, or 4 component vectors. Alright, get to 456, go have fun. So what I'm confused about is why this vector length here is returning a 0. Like, why is this black? This should be not black. This should definitely be like, what's the distance? You know, what is... This vector should be 128, and that is not 128, that is 0. You know, that's... It might be that we can't actually see it. So we have the distance from yeah, I think the spectral thing is broken. Like the distance from 0, 0, 0